Hi, welcome to Deuteron. I'm Björn and happy to welcome you. In our video tutorials we explain the basics and technical details of our product groups. This video is about our wax additives. Today I would like to introduce you to our wax additives. During our video I would like to talk in detail about the following topics. A short introduction to wax-based additives, why are wax-based additives used and how do they work, what waxes are available, how are they incorporated, and possible applications. Finally, we will end this training with a brief summary. The term wax is usually defined as a material that is brittle hard at room temperature and starts to melt at temperatures between 40 and 160 degrees Celsius. The melting viscosity is typically rather low. There is a large group of different materials that fulfills this definition and can be used as a wax additive. Wax raw materials can be divided in two different groups, natural and synthetic. Examples for natural waxes are beeswax, candelilla wax or carnauba wax. As coating additives, the natural waxes are a more exotic group with carnauba wax as its most common representative. The synthetic waxes cover a large group of different materials, mainly polymers. By far the most important polymer is polyethylene. Polyethylene is a multi-purpose material that delivers a well-balanced performance, nothing special, but well-performing in a majority of applications. Polypropylene is another highly important polymer. Polypropylene also delivers a well-rounded performance profile, but on a higher level compared to polyethylene. Especially the mechanical properties such as abrasion resistance and anti-blocking are improved. PTFE or Teflon also needs to be mentioned. Wax additives based on PTFE, usually in combination with polyethylene as a carrier, show an outstanding surface slip and scratch resistance. Another important group are synthetic amide waxes based on fatty acids. Amide waxes are an excellent choice for pleasant haptics and improved sanding. In addition, amide waxes are an important degassing additives in powder coatings. Besides these major synthetic materials, a huge number of other synthetic raw materials are used for specific wax additives. This includes, for example, oxidized polyethylene, paraffinic waxes, or ester-based materials. It is also important to mention that each raw material group contains several different materials with slightly different performance and properties. Also, the majority of wax additives are blends using two or even more different raw materials. Wax additives are complex and differences can occur depending on the coating systems, applications and test conditions. The supply form can be divided in two different forms, dry products and liquid products. Dry products are usually micronized fine powders with a particle size between 4 and 9 micrometers. In specific applications, even prilled waxes with particle sizes up to several millimeters are used. The biggest benefit of dry powders is their suitability in almost all coating systems. Liquid products are usually available as wax dispersions and wax emulsions. Technically, all these products are suspensions of wax particles in a liquid carrier. These liquids can be either organic solvents or water. Wax additives are used in almost all coating systems. They are multifunctional additives that mainly influence the surface of the coating. To explain the technical details how they work, we will use three different models: the floating effect, the ball bearing effect, and the melting effect. The easiest and most common mechanism is the floating effect. Most waxes have a relatively low density. In higher density coatings, they tend to float to the coating film. The floating process is supported by solvent evaporation and the resulting turbulences during the drying process. Another way for the particles to reach the surface is the ball bearing or overlay effect. Here the solvent evaporation and resulting film shrinkage are important drivers. When the solvent evaporates, the volume of the film will be reduced. This is called film shrinkage. The shrinkage leads to a significant reduction of the film thickness. The wax particles start to concentrate and lay onto each other. In the end, after drying, there will be a homogeneous distribution of wax particles within the film, where overlaying particles look out of the surface. The last mechanism is the melting effect. Melting occurs when the coating is exposed to a high heat, typically in can and coil coatings or powder coatings. The heat melts the wax particles. The molten wax quickly starts to float to the surface and forms a thin closed layer of wax on top of the film. In most cases, a mixture of floating or overlay occurs and leads to the performance improvements of wax additives. Deuteron offers a well-rounded selection of wax additives to address the majority of customers' demands. Starting with the wax powders, with Deuteron Wax-A, we offer a pure amide wax. Deuteron Wax-A is a plant-based product with low yellowing and great thermal stability. Deuteron Wax-PE is a polyethylene wax with medium molecular weight. Polyethylene wax is always a good starting point for first trials. Deuteron Wax-OPE is an oxidized version of our PE wax. The oxidization leads to a higher melting point and increased polarity. Wax-OPE is a highly suitable wax for water-based systems and acts as an excellent matting wax with great mechanical properties. Deuteron Wax-PP is a modified polypropylene wax and can be seen as a generally higher performing grade compared to polyethylene. Deuteron Wax-TF and TF105 are PTFE modified waxes. The term PTFE modification describes a synergistic mixture of polyethylene combined with PTFE. Such mixtures support a low surface slip and significantly improve the scratch resistance. Apart from wax powders, Deuteron also offers a range of liquid dispersions. Our WD products are available for Deuteron Wax-A, PE, OPE and TF105. Last but not least, we offer several specialized wax additives. Deuteron UV RMP is a wax alloy designed for matting of 100% UV curable systems. Apart from that, UV RMP can also be used as matting additive in difficult to matte systems and significantly improves the feel and haptics. Deuteron OG250 is a special paraffin dispersion for improved water resistance and block resistance. Deuteron AP348 is a polyethylene wax especially for the matting of powder coatings. Deuteron AP348 is only available as prills and thus not suitable for liquid coatings. The incorporation of wax additives can be easy or difficult depending on the system and kind of additive. The supply form is an important factor to decide how a wax additive is properly incorporated. The term incorporated means a complete distribution of the wax particles without the presence of agglomerates. The applied coating should be smooth without any particle-caused defects. The proper dispersion of wax powders can be difficult. Often high shear forces are needed to overcome cohesive forces within the agglomerates. Critical factors for the dispersion are the dispersing force or stirring speed, the dispersing time, and the addition speed. The most important factor is the coating system itself. Whereas solvent-based systems are usually rather easy, the water-based systems can be difficult. This is mainly because of the high polarity of water. In addition, the trend to low VOC systems and lower residual emulsifier makes it even more difficult to properly disperse wax powders in modern waterborne formulations. Especially for such critical cases, we developed our new water-based dispersions. The Deuteron WD products are waxes pre-dispersed in water. As an easy-to-use liquid, they can be poured in and dispersed using gentle shear force. It is important to mention that our WD products do not contain any surfactants or emulsifiers, and thus need slightly more shear force compared to traditional wax dispersions. The process can be improved by adding the dispersions while stirring. Wax additives are used in almost all cases where a particle-related surface effect is needed. The most important surface effects influenced by wax additives are scratch and abrasion resistance, the coefficient of friction, the block resistance, haptics or soft touch, and matting. As you already see, the majority of the influence factors are somewhat related to the durability of the film. Typically, the coefficient of friction is closely linked to the scratch and abrasion resistance. In principle, if a surface is slippy, more force is needed to cause any damage. Otherwise, the damaging material will simply slide over the film without damaging it. The most efficient materials to improve the coefficient of friction and impart scratch resistance are PTFE modified waxes like Deuteron Wax TF and Deuteron Wax TF105. Also, Deuteron Wax PE can be used for basic scratch resistance. For the abrasion resistance, the hardness of the material is another key characteristic. Waxes like Deuteron Wax PP and Deuteron Wax OPE are the first choice when abrasion resistance is most important. The hardness and melting point are also important for the anti-blocking properties. Deuteron Wax PP and Deuteron Wax OPE are again the best choice, but also Deuteron Wax TF shows a good performance due to the high polyethylene melting point. For the haptics of the film, the waxy character of the additive is important. This waxy or greasy touch can be mostly found with Deuteron Wax A and Deuteron Wax OPE. Both products lead to a very pleasant and characteristic soft touch. Deuteron Wax PP is another possible candidate for a pleasant and smooth feel. Now we are nearly finished with this tutorial. I will quickly summarize this training session. Wax additives impact all surface-related properties of a coating film. The final effect is defined by the material of the wax and by the particle size distribution. Waxes are available in powder form and as liquid suspensions. Powders are universal to use but sometimes difficult to disperse. Dispersions are easy to use but limited because of the used solvents. The incorporation of waxes needs shear forces to properly disperse agglomerates. Especially in water-based systems, the proper dispersion can be challenging. Please keep in mind that waxes are multipurpose additives. They usually influence a mix of different surface properties with a focus on a particular property. Besides all positive properties, it is also possible to get negative performance, just like every additive. Choosing the right wax is a matter of carefully evaluating the pros and the cons of an additive. We hope that this was helpful for you. If you have any further questions, please do not hesitate to contact us. Maybe we meet you in person soon at one of the next trade shows. Do not forget, our documents like product data sheets, safety data sheets and brochures are available in the download section on our website. They are completely free and without registration. Other documents, for example regulatory information, are available on request. We look forward to welcome you to our other product videos. Thank you for watching.